So, let's talk about it. The water cycle. We have stages 1 to 6: evaporation, condensation, precipitation, collection, infiltration, and transpiration.
The first one is called evaporation. Evaporation is the process by which a liquid turns into a gas without boiling. It usually happens at the surface of a liquid when particles gain enough energy, usually from the heat, to break free and become vapor. For example, when you leave a puddle of water in the sun, it gradually disappears. That is called evaporation. The water molecules at the surface gain heat energy and turns into water vapor and mixes it with the air. What is the role of heat energy in this process? Evaporation plays a vital role in the water cycle by helping to move water from the Earth's surface into the atmosphere. When the sun shines on bodies of water like oceans, lakes, and rivers, it provides heat energy. This heat causes the molecules at the surface to gain energy and escape into the air as water vapor. Even though the entire body of water is not boiling, some surface molecules gain enough energy to change from a liquid to a gas, and that is evaporation. As water evaporates, it rises into the atmosphere where it cools and later forms clouds through condensation. The more heat from the sun, the faster evaporation happens. The process is important because it not only keeps the water cycle moving, but also helps transfer heat from the Earth's surface into the atmosphere. In this way, evaporation connects the Earth's water and air systems, making it an essential part of weather, climate, and the distribution of fresh water. So, evaporation is a liquid that changes into a gas or a vapor at the surface without needing to reach boiling temperature. And it works because the heat energy from the sunlight, warm air, or another source causes water molecule at the surface to move faster, and that is called evaporation.
Hello, my name is Ahmed Alamin, and I will be talking about condensation. Now, you might be wondering, what is condensation? Well, it's the process by which a gas turns into a liquid. And now you might be having a little more questions about this. But let me give you a little scenario first. Imagine you're running to a car and it's hot outside. You quickly bolt over, you lock the door, and you blast the AC. And then after a several amount of time, you start to notice there's little tiny water droplets on your windows. Those little water droplets is condensation. Now, basically, how it works is the heat energy from the gas, aka the water vapor in this scenario, loses its heat. Then the molecules proceed to move closer and slower. And because of this change in the molecules, due to the release of heat, we have a change from something that was a gas to now something that is a liquid. And finally, this release of heat in this environment is called latent heat. And for anyone who's listening, thank you for that, and adios, bye-bye, from me specifically.
So what is precipitation? Well, precipitation is the step right after condensation. Basically, it's when enough water vapor has condensed, they become big enough to form a cloud. And inside those clouds is when droplets begin to grow. And yeah, this is how precipitation occurs. This is how water returns to the Earth's surfaces, refilling rivers, lakes, and groundwater. So precipitation is an important part of the water cycle that brings water from the atmosphere back to land and oceans. So what's an example? An example of this is when you see water falling from the sky during a storm or rain or on a cloudy day. That's what you call an example of precipitation. So what is the role of heat energy in this process? So while heat energy doesn't directly cause precipitation, it causes evaporation. And evaporation is very important for the whole water cycle thing. Because without evaporation, well, water just can't evaporate. And it can't turn it into water vapor. No water vapor means no clouds, and no clouds means no water anymore.
Collection is the process in the water cycle where precipitated water gathers back on Earth's surface. After precipitation, like rain, snow, or hail, falls to the ground, the water flows and collects in different places, such as rivers, lakes, oceans, and underground reservoirs. Some of it also gets absorbed into the soil to become groundwater. An example of that would be rainwater flowing into a river. But what is the role of heat energy in this process? In the collection stage of the water cycle, heat energy has limited but future role. During collection, water gathers in oceans, rivers, lakes, and underground sources after falling as precipitation. At this point, heat energy does not directly affect the collection itself. The water simply gathers due to gravity. However, once the water is collected, heat energy from the sun becomes important again. So while heat energy doesn't cause collection, it prepares the collected water for the next cycle by providing it the energy needed for evaporation. It's like the fuel that keeps the water cycle going round and round.
The next one we have is infiltration. Infiltration is the process where water soaks into the soil from the ground surface. When rain or melted snow reaches the earth, some of it seeps down through the soil and porous rocks, moving deeper underground. This water becomes part of the groundwater, which can feed wells, springs, and underground rivers. After a rainstorm, some water soaks into the garden soil instead of running off into the street. That's infiltration. Now, what is the role of heat energy in this process? In infiltration, heat energy plays a minimal direct role because infiltration mainly depends on soil properties and gravity. However, heat energy indirectly affects infiltration in a few ways. First, heat from the sun can warm the soil. Second, warm temperatures can dry out the soil. And third, in colder conditions, frozen soil can reduce infiltration. So while heat energy doesn't directly cause infiltration, it influences soil conditions that can either help or limit how much water soaks into the ground. Now, last one, we will talk about transpiration. Transpiration is like plant evaporation and is a major way water moves from the land into the atmosphere. Together with evaporation from soil and water bodies, it contributes to the moisture in the air, which can later form clouds and precipitation. Examples of that: after watering plants, you might notice humidity around them. That's because partly of transpiration releasing water vapor into the air. What is the role of heat energy in this process? Heat energy is essential for transpiration because it provides the energy needed for water to evaporate from the plant's leaves. When the sun heats the leaves, it increases the temperature, causing water inside the leaves to turn into water vapor. This water vapor then escapes through tiny pores called stomata. Without heat energy, the evaporation of water inside the leaves could slow down or stop, reducing transpiration. So basically, heat energy drives the movement of water from the soil through the plant and out into the air as vapor, helping keep the water cycle moving.
It supports all life forms. Plants, animals, and humans all rely on fresh water to survive. The water cycle ensures that water is continuously recycled and refreshed, providing clean drinking water, growing food, and habitats. It also purifies water. As water moves through evaporation and condensation, impurities are often left behind, helping to naturally clean the water. It also helps maintain Earth's ecosystems. Rivers, lakes, wetlands, and forests depend on the water cycle to stay healthy. It helps replenish groundwater and keep these ecosystems balanced. Why it matters? It matters because it regulates climate by moving heat and moisture around the planet. The water cycle helps control weather patterns and climate. Evaporation cools the surface and precipitation delivers water to dry areas. And it also supports agriculture and industry. Farming, manufacturing, and energy production all rely on water supplied through the water cycle.
So, that is all for this presentation, and thank you for listening to the end.